So, hello, welcome to my talk, Fuzzing the Phone in Your Phone. Short introduction, why is the talk named Fuzzing the Phone in Your Phone? So, in the earlier days, all the people just fuzzed like web browsers or some other applications on mobile phones or smartphones. And this talk is about actually fuzzing a phone-relevant part, SMS, on smartphones. So I'm a PhD student at TU Berlin here, and I specialize in smartphone security. And this talk was actually joint work together with Charlie Miller, a security researcher, well known for some iPhone and G1 hacks, the first ones. Pretty smart and cool guy. So, agenda, first I will give a short introduction on SMS. What is SMS? Then what are the difficulties with fuzzing SMS? Then we show how we do or how we did iPhone, Android, and Windows Mobile, SMS injection and SMS fuzzing. And then I will show some interesting fuzzing results. So SMS, everybody knows it. You send like these nice small text messages to other people. Normally, you can send like 160 7-bit characters or 140 1-byte characters to other phones. Everybody just knows it for text messaging, but you can also deliver binary data, which is normally used for over-the-air configuration or ringtone downloads. MMS uses it. The iPhone visual voicemail also uses it. And it's really an essential part of the whole mobile phone service infrastructure. So without SMS, many things don't work. For example, if you get a new voicemail, then you get this SMS which tells you, hey, you have a new voicemail. And so why would you attack SMS? First, since it's an essential part, every phone, every operator supports it. There's no real firewalling done for SMS. Some operators have infrastructure to do some filtering, but on the phones it's basically unfiltered or not filterable by the user. And it's really, the nice part is no user interaction is required. So for an email, you still have to like open the email, start the email client, whatever, to get exploited. But with SMS, it's like the 90s with servers. You just send something and bang, you exploit it. And the other nice thing is you just need a phone number to attack somebody. And where you get a phone number, hey, can I have your business card? So it's really, it's a fun part. And if you find something, you can have a lot of fun with it. So how does SMS work? Basically, it's a store and forward service where from your phone you send something to the infrastructure, and the infrastructure then sends it to another part of infrastructure, like another SMSC, and that other SMSC then delivers it to the recipient. Or if both phones are handled by the same SMSC just delivers it to the other phone. One small interesting part is that you actually have two slightly different formats for SMSs. One is the format that is used when a phone sends an SMS, and one that is used when a phone actually receives a message. This is kind of interesting for the fuzzing part. So SMS deliver is actually what we were mostly messing with. But on the device, there's a whole nother picture on how SMSs are actually received by the phone and then handled by the different applications. So first, most of the modern smartphones actually have two processors. One is the application processor, like in your PC, which runs this operating system, like Android, Windows Mobile, or your iPhone OS X. And then you have this second processor, which is basically the modem. It has some specialized real-time operating system. And both of these CPUs are basically just connected via a serial line, at least from the application perspective. Underneath, it may be connected via SPI or some other obscure bus. But have a serial line and still have these old cool AT commands. So this is just some arbitrary CPU from Texas Instruments, which is your big CPU which runs your OS, and then you have your modem down here. And you see, in the default, you have this UART, a serial line where you can actually talk to the modem. So how, when an actual SMS comes in, it's received by the modem, decoded, and then the modem just dumps out these two lines. First you have the command for, hey, here's a new SMS, and now you get 30 bytes of binary, and then you get the binary in hex, which is the complete SMS with sender number and the data at the end. That's basically how your iPhone gets an SMS via plain old AT command. But an SMS is not just text, so you have this PDU, we have all the different fields, type of address, then the SMSC number, and you have other coding schemes, and then you have user data header, user data, which is just the payload. So this was a very simple example. Then you have extensions like the user data header, which is used for mostly for delivering different binary protocols. So for example, this is one user data header which says, okay, this SMS is part of a bigger SMS. So this is the user data header for multi-part SMS. So this is actually the identifier. Then you have the length, and this down there actually tells you, okay, we have total parts of 3. This is the current number is 3, which already gives you a good idea where you want to go with fuzzing later. So then you have other user data headers. So for example, the voicemail indication, which is used for mostly in the US, as far as I know, not here, where you can actually set some nice icons on your phone, which tells you, hey, you have a new voicemail, and you have port addressing, like this TCP/IP. You can actually say here, send this SMS goes to a port. So for example, this is the iPhone visual voicemail, which is just sent to this port. And which is basically a URL where the iPhone then gets something. Then you have stuff like push. So this is just port addressing. When you begin looking at SMS, then maybe you don't want to read the specs right away, so you get the nice tool PDU spy, where you can just take these messages you get out of the serial line and put them in here. Then you get a good example of what is actually used, what is there. And if you later generate your own SMSs, you can use it in the beginning to do some validation. Okay, now to fuzzing. First, a small introduction what fuzzing is. Basically, fuzzing is you take some input to some application protocol. You create like malformed input. So either you take some existing input you captured from the network, you mutate it a little bit, give it to the application, see if it crashes. Do it again until something happens. So either you can take some existing, mutate it, or what I prefer actually, like read the specs and implement your own generator to generate these malformed messages. Of course, you don't want to do that manually, so actually you want to set up some fuzzing framework where you generate this malformed input and something to record interesting events, crashes, detect if the device hangs, because it's not a piece of software on your computer which you can just kill -9 restart on the phone. You actually have to really see if the phone totally hangs, and then maybe have to reboot it or reboot parts of it. And then you have dialogues. So this gives you some additional hurdles on mobile phones to do it like really complete unmanned automated, because your primary goal is to set up the fuzzer, go to bed, and wake up with some 0 days the next day. So again, this was like a group team project. Charlie went for using Sully, which is a nice Python framework to do some generation mutation, and I built this crafting library. So I will mostly talk about some crafting. So basically, my crafting library I basically first started supporting the SMS deliver, since that's used on the phone side to actually be delivered from the modem to the application, which we want to fuzz. So I implemented the most widely used UDH headers or user data headers, like the port addressing, multi-part, this indication thing. And later we also implemented submit, since at some point you want to actually send an SMS over a real phone network to a phone to actually see if the crash you found really works in the wild and is delivered on the network. So my test cases basically just covered like this multi-part port addressing. So we also built this nice port scanner, because you have also 64K of ports, which you normally don't want to scan over a telephone network, because for each port you would need to send an SMS message, and even if you pay a couple of cents, this gets highly expensive, especially if you want to target more than one phone. So yeah, and then we have this UDH bomb, as I call it, where I just generate random UDH headers, just concatenate them together, because you actually can put multiple UDHs in one message, and then some voicemail indications. So this is the stuff we mostly did. So actually all the stuff I'm going to show today is available at this URL, so the libraries and the injection tools I'm going to show you in a bit. So now that we figured out, okay, how SMS messages are delivered, how they look like, we actually start wondering, okay, how do we do the testing? Because if we send over the air, so over operator, yeah, we have to pay a lot of money. Also, the operator actually sees, hey, some guy is sending like 50,000 SMS in the last 2 hours, so maybe we do some monitoring. Yeah, and the thing you really want to avoid is causing some crashes on the infrastructure, because then they will probably be very pissed at you. Then, of course, if you attended like the talk from Harold, you can just take your own base station, but yeah, we're software guys, so setting up a base station, maybe in some RF-shielded room, it's a lot of work, you have to spend some money. Then we thought, hey, we could also maybe debug the processes, do some memory injection, but this is really something we don't want to do, and if the firmware changes or anything, we have to redo everything, so we came up with another idea. And that is to man in the middle, actually between the modem and the application stack. So we actually manually built on the serial port to just emulate the modem to the application stack. And some really nice benefits are, of course, you can send way quicker, since there's no operator in between, no modem parsing. It's completely free, no special equipment. The process actually don't see that anything special happens, since there are not being debugged. And the test code doesn't see it, so you have your 0 days for yourself. But at the end, you will have to verify actually that all the messages or the generated PDUs that do something, some crash, actually work on a real network. So there's some additional work at the end. But you just have to make sure that you think about that before you report bugs and say, hey, we cannot actually send this over the network. It's quite nice. So in general, so our injection layer looks like this. We have the modem down here, then we have the virtual serial lines, OS dependent, so sometimes you have a device file in /dev, sometimes you have some DLL. We just put this small injector software there. It just passes AT commands from the modem to the results from the modem to the stack, the command down. And then we have this small additional thing which allows us to take the small plus EMT line where you say, hey, here's a new SMS. And the one additional thing, you actually also get SMS sniffing for free. So everything that comes in to the application stack, of course, only if something is already handled by the modem or maybe the SIM toolkit, you don't see that. But for everything else, for like the custom applications like the iPhone visual voicemail, you just see everything is on there, what happens. And it's nice for reverse engineering too. Since everything is for free, the fact that it's free is actually a really essential part of this whole SMS parsing and exploit development we did, because if you send thousands or hundreds of thousands or millions of SMS, it gets expensive, and then you want to do some exploit development, and you pay more and more. So without our injection framework, this whole thing wouldn't okay, we have to find a way that we can send SMS for free and fast. But free was the main issue. So if you every time you send like an IP packet somewhere on the internet, you have to pay like for every packet like 10 cents. Yeah, fuzzing or scanning, you don't want to do that. And the same is with SMS. You have to pay that, but with free access. Okay, so our first target was of course the iPhone, because iPhone is everywhere and it's so great and it's so cool, and yeah, Charlie is a big iPhone fan, and so the first target was the iPhone. On the iPhone, yeah, we have this one process called COM Center, which basically handles all radio communication on the device. So it handles GSM, UMTS, Wi-Fi, Bluetooth. And the nice part with it is, yeah, it runs as root, or at that time it runs as root and with no sandbox. So if you own that process, you own the phone, maximum access on the phone. Which, when we found it out, yeah, it was quite funny, because we said, hey, that's the thing we want, or everybody wants to own. It's a small fun fact. So on the iPhone, you actually have these 16 serial ports, depending if you have a 2G or a 3G one. This is the device files. And what we basically did is we started with just inserting a library into the process with just preloading, using the COM Center's plist. We just inserted this library which just intercepts open, and if the interesting serial port was opened, this is so serial port 3, and actually on the iPhone there are 2 serial ports we have to hook in, those 3 and 4. Then we just redirect it to a Unix domain socket, which actually is our injector, and runs on the phone and listens on the TCP port, where you can just send those plus CMT commands, and which are then injected into this process. And yeah, the injector just runs on, listens on Wi-Fi, so we can just sit there on the laptop and develop all our testing tools just on our laptop and just send them over Wi-Fi to the phone. And the injector was actually stable enough that I could just have it running all the day. The phone just continues to work as normal. And so testing was actually pretty stable using this technique. Actually, just to send a command, we just generate a PDU, throw it into this 5 lines of Python code, and yeah, send some SMS to the phone. So just sending SMS or messages is of course not enough, because you have to actually see what happens. So you have to monitor for crashes. And the nice part on the iPhone is that you actually don't have to debug the process to see what happens, since if a process dies, Crash Reporters makes a nice crash dump. And so what you can actually do is send an SMS, check if a new crash reporter file was generated for the COM Center process on the phone. If it was, you just copy the crash dump file and save it together with the input that generated the crash. And then you just continue, so you have very easily fully automated testing. Of course, you don't only want to test for crashes, since maybe the process just hangs and does not handle new SMSs that comes in. So you actually also want to check if the process hangs. So what you actually do is we send a fast SMS. If nothing happens, we send another valid SMS that just has some text, and then we just query the SQLite database on the phone to see if the SMS is in there. If it is, we delete it and just continue. Because we do this because there was this, I think last year at the Congress, there was this bug which we sent an SMS to a Nokia phone. It just stops receiving further SMSs, and we thought, hey, maybe we catch something like that. So, and as I told you earlier, there are multiple user data headers that are existing in the SMS standard. And of course, we don't only want to build test cases for the ones that are actually implemented on the phone, because why test a protocol or part of a protocol that's not even implemented? So we run the comm center through IDA and just found this nice, there's actually some switch case statement somewhere where they actually switch on this 1 byte, which tells the type of the UDH. These are all the supported types, so we only build test cases for these 5 UDH things. Just saves you a lot of time with just looking into IDA once. Okay, so now Android. Yeah, the not fun fact on Android, like all the stuff is written in Java, but we will still have fun with this. And on the Android, it works the same. You have this serial device called SMD0. And what we do is since it's a Linux, you just rename the device file, write our daemon that creates a fake PTY with the original name, then we kill the radio interface daemon. Init brings it back up, and as soon as init brings it back up, it will just talk to our fake interface as it was the normal one, and everything is running like on the iPhone. Same on the iPhone, port 4223, and we can just continue using all the test tools we just implemented for the iPhone. So the Android implementation was like a half day, the iPhone implementation was like 3 days, 4 days to figure it all out, but yeah, then Android came half a day, 1 day, and everything was working as before. Crash monitoring, of course, is a little bit different on Android. So you have this Android debug bridge, where you can just say, okay, give me the output of the log. And yeah, the thing we want to look for is like these stars, which indicates basically a crash. So again, we just run the ADB command with this logcat and just grab, or not grab, it was done with a small Python script which just reads the output and searches for the stars, and if something happens, again, the output of the log crash is saved, and the SMS which generated the output is saved again. Fortunately, SQLite is also the SMS store on the Android, so we could just basically reuse everything again. Just the tables, of course, look a little bit different. The bad problem, or the problem with Android is like it's a little bit flaky at that point in time. It was a little bit flaky, so sometimes it was not really responding. So yeah, we had all those different steps where we first kill the phone process and kill the MMS process, which is also the SMS process. And if that doesn't help, yeah, we basically kill the system server, which is almost a reboot. So you have to always make sure the device is in a kind of a clean state, otherwise the fuzzing your fuzzing results will not be as good as you want them to be. And when we were done with those two Unix-ish platforms, we thought, okay, we can do it on Unix. We have to also find like a non-Unix platform to see if actually can get it working there. So I knew a little bit of Windows Mobile programming, so we thought, okay, let's try it on Windows Mobile. But yeah, Windows Mobile is it's different. You have to do all kind of nasty hacks to get your own applications, and especially if you want to like get your own DLLs or drivers onto the phone, you have to do all this nasty stuff. And actually, it took way more time to build this injector for Windows Mobile than the other two platforms together. So on here, we added a new serial driver, or actually we reused the log driver from this nice person over there. Thank you very much. So then we just added another thread for the TCP port to actually get the data into the driver, and then we have exactly the same setup. The +cmt command is exactly the same, and also on the other phones. And so we were back into the game with Windows Mobile message injection over Wi-Fi. So monitoring on Windows Mobile is pretty hard, and takes a lot of joy out of the whole thing, because you actually have to debug the process in an active way. So you actually have to debug hook up a debugger to the actual receiving process. And on the device we used for testing, which were HTC devices, or one HTC device, we actually have two SMS applications, one from Microsoft, which is just part of the OS, and then we have this HTC Touch Flow, which is a complete GUI for the phone, which has the call stuff, contacts, web browser, SMS, everything in one application that comes up on default, and basically just the complete user interface. And we actually decided to only go for this one, since we thought, okay, the Microsoft stuff has been around for a longer time, and this kind of looks more interesting. So now to some results. Of course, we got all the devices to crash in many different ways, but again, the only crashes that actually are reproducible over a telco network are worth anything. Everything else is like, if I can inject anything to any process without going through any kind of validation, you probably can get it to crash, and so. What we did, all the stuff we found, we sent it over a real telco network, and everything that went through are real attacks. So what we actually did is we wrote a small application for the iPhone, just command line, where you can just paste PDUs, which we can take out of the fuzzer and directly paste it into the application and send them to any phone number. And it was a really great testing tool, but later then we used it for demonstration. It's actually pretty nice if you can pull out your phone, just ask for a phone number and kill somebody's device. But the interesting part is we actually have to test on different network operators, because some operators switch off some features, or because of maybe a different type of equipment, some stuff is just not delivered on certain operators, or especially between operators. So this is a whole nother thing you have to do after actually validating that your exploit or bug or whatever test method that does something works on one operator. You have to still go out and test on other operators. Of course, we did not test all operators, just some in Germany and some in the US. This, just a small application to actually, I don't know if I actually released that, but at some point I will. It's just some SMS sending tool, which directly takes PDUs. So the first thing I will actually start at the bottom, because that was actually the first bug we found, is some really stupid flash SMS bug, where if you send a flash SMS with just one byte, where the highest bit is set to 1, actually Springboard crashes. If you know, Springboard is the GUI or window manager of the iPhone. So if that crashes, any application that currently runs gets terminated, and the phone writes a crash dump, locks the phone for about 15 seconds, because you need some time to write actually the crash dump to flash, and then you're back at slide to unlock. So this very, very boring DOS. But then we found something that can actually crash comm center. And since comm center handles any kind of radio communication, it totally cuts off the phone from any kind of radio. So it actually turns your iPhone back into an iPod Touch without Wi-Fi. And as an addition, actually, if there's a phone call in progress, it's interrupted. So this is, normally you say in the computer world, like, DOS attacks, you cannot go to a conference where you say, hey, we have found this cool DOS attack. But being able to kick actually a phone off the network is quite cool, and if you actually can selectively interrupt phone calls, that's even cooler. But it gets better. So just here, that's just how it looks like. You get the SMS and your phone goes back to searching, and at some point you're back. So then we started looking at Android, and Android apparently has the same kind of bugs. The triggering is completely different, but we also found this bug, okay, we can actually kill this COM Android phone, which is again the process that handles the mobile phone network. And we could also kick Android phones off the network. But as an addition, On Android, actually, when the phone application restarts, it resets the modem. So if you have a PIN set on your SIM card, which you normally have if you live in Germany and some other European countries, in the US you don't have a PIN, so if you explain it to US people, you have to say, oh, you have actually a SIM card PIN in Germany. So the fun thing is, because you reset the modem, your phone comes back, or the process comes back up, and your SIM card is locked. So you cannot register, your phone cannot register to the network. And the nice thing is, this is totally silent. You don't hear the SMS, nothing happens, you're just disconnected. So if you have the phone in your pocket, you just cut off until you check your phone, and then you see the screen. Okay. So normally, if your phone is unlocked, you'll see this crash dialog, but if the phone is locked, it just disappears, and when you press on any button, you actually come here. Pretty nice, but it gets even better. So then we went after Windows Mobile for a bit. So for this touch flow thing, and we found, hey, there is this SMS which actually kills touch flow. And as long as the SMS stays in the SMS database, touch flow does not come up. You can reboot your phone, you can do everything. If you don't delete this SMS, touch flow is dead forever. Of course, you have to know, the fix is totally trivial. If you used any other other Windows mobile phone before, you know, hey, there's start, and I go to Pocket Outlook, and then this is this SMS folder, and then you find this SMS, can delete it, and then everything is back to normal. But as a normal user, you're basically stuck with the hard reset to clear whatever you have in your SMS database. If you don't know what you're looking for, then it's really bad. That's basically how it looks like. Then you get to this crash report. Do you want to send it to Microsoft or not? Whatever you do, you will always be here, which says like, touch the screen to restart touch flow, and then you go back there and back there. You will laugh even more if I show you the bug later. But so let me see. Did I? No. So for the first crash we found, or for the first bug I showed you for the iPhone, which was this crash com center thing, we actually did this nice demo at Black Hat, where we sent to a friend of us, we sent this SMS every 10 seconds for like almost an hour. And since he was roaming, the SMS were very slowly delivered to his phone. So at some point, we stopped sending the messages. We didn't tell him. He was sitting somewhere in the audience, and later afterward, he came to say, hey, can you stop sending this? Like, hey, I stopped this like 1.5 hours ago, and he said, like, I'm still offline. And then when I met him later in the evening, he said, like, hey, he was actually off the network for like 2.5 hours, something, after the talk. So yeah, because the SMS just sits in the gateway because it's a store and forward system. So if the SMSs queue up, if the phone comes to the network, it's knocked off. Then the process restarts, 10, 20 seconds. Another SMS, so they're very slowly delivered to the phone, and then of course you stay offline for a very long time. But yeah, we can even improve that. So 2 weeks or 2.5 weeks directly before Black Hat, Charlie was bugged by some other people, like, hey, you can do better than showing some denial of service. So he sat there and basically got remote code execution working via SMS. Yeah, I don't show any details like the slide says. I can write some exploits. I never done it for the iPhone, but the basic story is you send 519 SMS, where only one shows up because the whole bug is this multi-part SMS, and normally with multi-part only if the complete message is arrived, all the parts, then the message is assembled and sent up to the stack or further up to the stack. And he basically showed, okay, we can get program counter control via SMS. And for this, we really need this injection framework to test it out because, I don't know, for 2.5 weeks, he was just building, trying, modifying everything, and it would have cost a lot of money and a lot of time just to try it out if something like that would work. So some more details on each of the tags. So on the Android, it was you could send just one byte to the web push port, and then you get a cool array index out of bounds exception. Yeah, it worked on most European countries, but unfortunately not on AT&T. We still haven't figured out why. And again, this is a really good example why you need to test on the phone, because if we would only have tested on AT&T, we would never have found this bug, because this SMS would never be delivered to the phone, so we could never find the bug. And with all the bugs is, yeah, if the carrier is blocking it or something happens to it because of some equipment restrictions or whatever, you do not find all the possible bugs. So it's really important to test without this intermediate operator network. It was just a nice example. Yeah, it's basically, yeah. This is the output of the ADB process, and down here you see this nice array index out of bounds exception in VSP, so somewhere in the WAP decoding part. And now, yeah, Windows Mobile. Yeah, so I don't know why. So the basic bug is here. You send 1%n in a text message, no binary, nothing. You can type it on your phone and send %n to any HTC TouchFlow version 2 phone. And yeah, we haven't tried to really exploit the format string for code execution, but it should work. So maybe somebody is eager enough to do that. Apparently the bug is fixed, but yeah, I haven't been able to download the updated firmware. Yeah, so almost done. So the conclusions: SMS is a really great attack vector for smartphones, or possibly also for other non-smartphones. Yeah, if you think a little bit outside of the box, you don't have to be limited by some equipment. Just do local modifications on the phone. And if you really just inject them locally in software, don't leave. There's one slide you want to stay for. And yeah, so we only did very limited fuzzing because we wanted to make a point that we can actually break into most modern smartphones with SMS, which is like really, really, really old. So all the tools like for injecting and testing, they're all published, and somebody just needs to take some more time and do more testing, because as soon as we found something interesting enough, we actually stopped fuzzing more, especially on Windows Mobile. I think it was test case number 5, which triggered the %, and we thought, okay, this is a joke. And then we actually stopped, especially because Windows Mobile is kind of, it's not very fun to fuzz it because of the whole debugging issue, but if somebody has some time and is interested. So okay, so about the bugs. So of course we reported all the bugs. Android or Google has actually had a patch cycle already scheduled, so they actually got the patch out 2 weeks before we did our Black Hat talk. Yeah, iPhone OS was patched on the day after the talk, or the patch was released. And the fun fact, especially for us, is the patch was only for our bug, so yay. And yeah, apparently, so if you have an HTC Touch 3G, you want to have this ROM build, apparently. I haven't tested it, but the HTC guys told me, okay, this is a ROM build which actually fixed this, but yeah, if I haven't found a way to download it, yeah, so I haven't installed or tried it. So, %n. You can type it on into any mobile phone, of course, but then, of course, you see who sent, or the receiver sees at some point who sent it to you. But since it's really just, you don't have to do any fancy things, it's just a normal text message, you think about interesting other ways. So you have this bulk message SMS providers on the internet where you can just buy SMS for like 2 cents each, but then they have your credit card, they know who you are. So recently when I walked through Berlin, I recognized phone booths which has public pay phones, which is big SMS, send SMS from this payphone. But just buy some sunglasses. So actually, 2 days before the Congress, I thought, hey, my talk got accepted. Let's try out if it actually works. So there's this nice payphone at Alexanderplatz, and you can actually go there, and you have this full keyboard, because first we thought, maybe you just have like, you have to do like this alt where you have just the numbers, but we actually found that these big ones from T-Mobile, which internet access, you just have a full keyboard, so you can just type %n and off you go. So check out my new tool on the street. That's it.